planets so weird, even science fiction could not foresee them. For the first time ever, scientists are discovering alien worlds beyond our solar system. Places where ice is hot and rain is made of iron. They are uncharted, unearthly, and unpredictable. And somewhere, hidden among these strange new worlds, scientists seek the greatest discoveries of all. Planets like ours, alien Earths.
35 seconds. Let's go. Storage tank press closed.
March 6, 2009.
22 seconds.
Later, GN2 pressure go.
This Delta II rocket is going through its final pre-flight check.
71.3.
Drop 1.
Engine start, 1-0, and liftoff.
It is the start of an extraordinarily ambitious mission. The Kepler Space Observatory is hunting for planets like Earth within a region of 100,000 stars. It is the culmination of a journey that began more than a decade ago with one of the most profound scientific discoveries ever made. (1995). Swiss astronomer Michel Mayor and his team make a routine observation of stars in the constellation Pegasus, located 50 light-years away. But the instruments show something strange. One star is violently lurching and wobbling.
What we discovered, it's one of these stars have a velocity changing with time.
What is powerful enough to disturb a star the size of our sun? Mayor offers a radical answer: a planet. But no one has ever seen a planet around another sun-like star.
Problem in detecting planets around other stars is that as a planet orbits a nearby star, that planet gets lost because of its feeble light in the glare of the very bright star.
In spite of the odds, Mayor relies on his data and is convinced the wobbles are caused by the gravitational pull of an orbiting planet.
When I read this claim from Michel Mayor, I was very skeptical. There had been many false claims of the first planet ever discovered around another star, and I thought to myself, oh boy, here we go again. So I decided to observe the star on 4 consecutive nights. And stunningly, the star was shown to wobble exactly as Michel Mayor had said.
Michel Mayor and his teammate Didier Queloz announced their discovery. It rocks the scientific community.
They had found for the first time reproducible, confirmable evidence of the existence of a planet around a sun-like star.
Officially called 51 Pegasi b, the planet is nicknamed Bellerophon, in honor of the Greek hero who tamed the winged horse Pegasus. It is a planet that breaks all the rules. Bellerophon roasts in the blazing starlight at temperatures of roughly 1800 degrees Fahrenheit. It is nearly 150 times more massive than Earth and is a gas giant like Jupiter.
A gas giant is a planet made mostly of hydrogen and helium. Only the outer layers are gas, but inside, hydrogen and helium is compressed to huge pressures. It doesn't resemble a gas at all.
Unlike anything found in our solar system, this is an entirely new class of planet, what scientists call a hot Jupiter.
If you go to Hawaii and see the lava flow there, that's how hot a hot Jupiter is. It's very, very hot.
The Earth is a comfortable 93 million miles away from the Sun.
These hot Jupiters are roughly 100 times closer, and so the amount of sunlight that they get is 10,000 times larger.
If this represents a star, and this a hot Jupiter is 3 to 4 stellar diameters away from the star. So that would be 1, 2, 3. This is how close a hot Jupiter would be to its star. Hot Jupiters are tidally locked. They present the same face to the star at all times, just like the moon does to Earth.
It's going to be permanent daylight on one side and permanent nighttime on the back. If I were stuck on a hot Jupiter, I'd want to be on the back side and hope that some of the heat from the front side facing the star would make its way around the back.
The variations in temperature make Bellerophon's atmosphere extremely windy. The wind howls at thousands of miles per hour, far beyond anything we could ever withstand. The heat blast guarantees water vapor cannot exist. But that doesn't mean there is no rain.
It's far too hot for water liquid clouds to form here. But instead, these clouds would be made out of iron.
Iron vapor can exist at temperatures much higher than water. And because of that, things could get a little messy.
You better have an umbrella that's pretty sturdy, because the iron is going to start coating your umbrella very rapidly and making it extremely heavy and just crush that umbrella.
The sky overhead is filled with dancing curtains of color. Charged particles from the nearby star make auroras far more extreme than the northern lights on Earth. There is something even more unique about this newly discovered world. Bellerophon orbits its sun in a blistering 4.2 days.
No self-respecting planet goes around a star in 4.2 days. None of the planets in our solar system take such a short amount of time.
For scientists, the tiny orbit challenges long-held notions of how planets form.
The fact that the planet was orbiting every 4 days was a total puzzle until one night in the middle of the night I woke up and said, well, this must be proof that planets migrate inwards. They don't stay put where they are.
The key to the puzzle is found in how planets are made.
Planets are a byproduct of star formation. When stars form, they have a disk of dust and debris around them, and out of that debris, planets form.
Much of what we know comes from Hubble's Space Telescope, as it aims at regions like the Eagle Nebula. This interstellar cloud is studded with collapsing disks of dust and gas. A giant clump grows in the center of each disk. Temperatures reach a searing 18 million degrees. The same nuclear fusion that powers our sun is unleashed. The star is born. Radiation from the star generates a stellar wind that sweeps away leftover dust and debris. Some of the dust survives and remains in orbit around the newborn star. Over millions of years, the dust sticks together, forming knots that grow into asteroids, and the asteroids grow into planets. These planets migrate through the disk until they find a stable orbit. This is why Bellerophon is so close to its parent star. But one newly discovered world has found its stable orbit in a place no planet should ever go. 2001. Hubble Space Telescope is directed to an obscure star some 150 light-years away from Earth, in the constellation of Pegasus. This is the same region where Bellerophon was found 6 years earlier. Hubble is tracking another hot Jupiter, discovered by astronomer Jeff Marcy. But this one is different from Bellerophon.
You've probably heard of the planet HD 209458b. It's a terrible name.
A terrible name for a terrible place. HD 209458b has been dubbed by some as Osiris, after the Egyptian god of the dead. Osiris is over 200 times more massive than Earth. It has migrated perilously close to its sun, at a mere 4 million miles from the blazing solar surface. Osiris broils in a planetary hell. The average daily temperature on Osiris is over 2,000 degrees. Forget global warming. This is global frying, and it causes Osiris to lose an estimated 550,000 tons of air every second.
There's a leak of gas, a steady stream of hydrogen and helium, and that's making a big, huge cloud all around the planet.
Its atmosphere is bleeding into space. Scientists speculate that a colossal trail of gas spirals behind the planet for thousands of miles. Osiris presents an unprecedented opportunity for astronomers. Using Hubble, they analyze the alien planet's bloated atmosphere.
This is the absolutely first time where we could tell what is the composition of the atmosphere of an extrasolar planet.
Surprisingly, Hubble detects many of the basic chemicals needed for life. Sodium, carbon, hydrogen, and oxygen. But Osiris is far too hot for life as we know it.
There may be other forms of life, however, that thrive on higher temperatures.
But there's no solid surface as we know it on a hot Jupiter. So this life would have to be just tiny little microbes floating around on aerosols. And on our own Earth, we have life that floats around in our atmosphere. But that life didn't start there. So life almost certainly would not exist on hot Jupiters.
Astronomers have discovered many hot Jupiters since Bellerophon was found in 1995. But conditions on these worlds rule them out as places where the drama of life can unfold. One of these gas giants is a planet that teases the rules of evolution. Astronomer Jeff Marcy discovers something shocking about a planet orbiting a star called 16 Cygnus b, located some 70 light-years away in the constellation of Cygnus, the Swan.
The planet was clearly in an elongated orbit, bringing the planet close to and then far from the host star. And this, of course, defied our expectations based on our own solar system, where all of the planets go around our sun in nearly circular orbits like phonograph grooves in a record.
Like a giant yo-yo in space, the gas giant swings back and forth across its solar system, That is like the Earth swooping 25 million miles closer to the Sun, then slinging past Mars, all the way out towards Jupiter every year. And like all of the gas giants in our solar system, this yo-yo planet might have an entourage of moons. Marcy speculates that one of these moons could be similar to Earth.
And here's where the interesting story begins. Imagine a rocky moon with lakes, oceans, maybe streams and waterfalls on the surface. The moon orbiting its planet, the two of them orbiting the host star.
Unlike the airless moon that circles the Earth, this moon is a world with extreme seasons. On Earth, the seasons are caused by the tilt of our planet. Here, they are caused by the elongated orbit.
These poor planets that are in these elongated elliptical orbits suffer terrible changes in their climate throughout a year.
As they make their closest approach, the yo-yo planet and its moon are blowtorched by the star. Summer begins. The atmosphere on the Earth-like moon is savaged with raging storms. Category 5 hurricanes on Earth are tiny eddies compared to the monster vortexes that form here. The clouds thicken as the water evaporates.
Temperatures rise dramatically. Any water or gases would heat up, and indeed the oceans would boil into steam, so you'd end up with a big steam bath.
During the peak of the summer, the entire moon is smothered in 800-degree temperatures. This is the closest approach to the star. During its 26-month orbit, the summer season is barely 2 months long. But what a season! The planet and its moon swing away from the furnace of the star. Temperatures fall to ranges we would find temperate and comfortable. With the coming of fall, the rains return to the parched and roasted moon. Dry ocean basins are replenished, and the seas rise to form new shorelines. Tranquility prevails as the yo-yo planet and its moon slip into the deep freeze of winter. Now, over 200 million miles from the star, the daytime sky is dark. Temperatures hover around 260 degrees below. Winters are long, lasting 17 months. With the coming of spring, the sun looms large in the skies over this hapless moon as the ice cracks and melts violently. Huge icebergs calve into a stormy and fast-rising ocean. For 2 preciously short periods, during the spring thaw and the autumn rains, the climate on this Earth-like moon is balmy and comfortable. At a distance of 93 million miles from the star, roughly the same distance as Earth from the Sun, the elliptical orbit of this planet and its moon crosses an area around the star some scientists call the Goldilocks zone. The conditions here are just right for life.
If you're too close to the star, then it's too hot. If you're too far away, then it's going to be too cold and everything's going to be icy. But then if you're right in the middle, it's just right.
Every star has a Goldilocks zone. Where that zone is depends on the size and temperature of the star. In our solar system, Venus marks the inner boundary and Mars the outer boundary. Earth and its abundance of life is right in the middle. The Yo-Yo planet passes through the Goldilocks zone twice a year. For 3.5 months during the spring as it races inbound, and again in the fall for 3.5 months as it hurtles back into the colder reaches of space. Could life survive the conditions outside the Goldilocks zone?
There could be life forms that are smart enough to hibernate, as do animals on the Earth during the winter season. If this sounds fantastic, I offer you the tidal zones on the Earth. On the tidal zones, life proliferates, of course, near the seashore, and they do so despite tides. The water coming in, covering many of the life forms, the water going out at low tide, and yet those species survive perfectly well.
The strange cycle of the Yo-Yo planet's orbit creates fleeting conditions suitable for life, but also for death. Some alien planets are even more bizarre. Imagine a world that has no star to orbit. Scientists speculate that our galaxy is teeming with rogue planets, adrift in the murky lanes of interstellar space. These are orphaned worlds, planets that are booted from their solar systems by the chaos of planetary migration. Astronomers call such worlds planemos.
Planemos are planets without a star. They're just drifting through the galaxy indefinitely.
What massive force would it take to kick a planet out of the solar system?
When a young star forms with a contingent of planets around it, many of those planets gravitationally interact with each other. They yank on each other, slingshot each other, so that one of them is ejected from the planetary system, voted off the island, if you will.
If you were, unfortunately, a resident on a planet that was kicked out by a collision or a near collision with another large object, you'd probably rapidly move out of the habitable zone.
There are hundreds of billions of these lost, wayward, poor, wandering planets out in our Milky Way galaxy with no parent star to warm them up.
Cold, dark, quiet. Because planemos have no sun, they are worlds without days or years. They keep vigil through an eternal night. Planemos are solitary wanderers, sentinels of the galaxy. Just because it's out there drifting in space doesn't mean a planemo is dead.
If the planemo is a rocky world, it could well have life on it.
A small rocky planemo without an atmosphere will slumber in extreme cold, far colder than the coldest winter day on our own South Pole. But a planemo large enough to retain an atmosphere traps the heat generated when the planet was first formed. It is the ultimate greenhouse effect. The heat and energy comes from the molten core deep inside the lonely planet. If the planemo is a gas giant like Jupiter, it may have a system of moons. The gravitational pull between the planemo and its moons creates friction, causing the interior of the moons to stay warm.
These moons could also have life on them, in the same way that Jupiter's moon Io has volcanoes and has a lot of heat energy being generated by interactions with Jupiter and the other moons.
If anything lives here, it will be single cells, like common bacteria found on Earth. Not complex life forms. Without a sun to provide photosynthesis, these tiny organisms derive their energy from the chemistry in the soil of the planemo, or its moon. On Earth, there are similar conditions. Colonies of bacteria are found deep within mine shafts in South Africa. They have no access to oxygen nor light, and survive entirely on the chemicals they make from the surrounding dirt. Their metabolisms are extremely slow, and they reproduce only once every 1,000 years. If life dwells on a sunless planemo, it could be organisms like them, marooned when their planet was young. While planemos slumber undisturbed, there are worse places to be in the universe. Like in the company of this lethal pulsar, some 980 light years from Earth, in the constellation of Virgo. From afar, a pulsar looks like a blinking light. But up close, pulsars machine gun their surroundings with deadly radiation. They are no place for planets. Yet something interferes with the precision of this pulsar. One explanation is that the anomaly is caused by a planet. But many astronomers are skeptical that planets orbiting a pulsar can exist.
The reason that's a problem is because pulsars are formed in these incredible explosions.
When a red giant star explodes, a titanic fireball known as a supernova unleashes as much energy in 1 minute as our sun generates in its lifetime.
When a star goes supernova, the shockwave is so immense it's hard to imagine any planet surviving that.
When the cosmic dust clears, all that remains is the crushed core of the red giant, pulsing in the heart of an expanding debris field. Matter blasted from the colossal explosion falls back to the pulsar and forms a disk. Within this chaos, a new world arises, born of fire and destruction, a planetary zombie raised from the carcass of the former red giant star.
It's amazing that planets could form in that environment.
A planet orbiting a pulsar will give you the feeling of being in a disco bar with a very strong strobe light, which is the pulsar.
Radiation from this stellar beast breaks down the organic molecules needed for life.
The pulsar has these very strong magnetic fields that are being spun around as the star is rotating quickly, and it's picking up any material, electrons, protons, and speeding them up and slinging them out at high speed. So it's like a solar wind with a vengeance.
I can't imagine that there would be much of an opportunity for even simple life, microbial life, to emerge and to flourish on a planet around a pulsar. Largely because if you were in the pulse, you'd be severely energized, and if you were not in the pulse, you would be completely devoid of energy.
The discovery of pulsar planets shows how new worlds can form in the wake of a star's destruction. No matter where a planet arises, the process of its birth is fraught with danger. Sometimes, the violence is so great, the end of the world comes before the beginning. 2007. Astronomers using the giant Gemini North telescope make a strange discovery in the Pleiades cluster some 400 light-years from Earth. A star known only by its catalog number, HD 23514, is surrounded by a giant donut-shaped cloud of dust and gas. The star in the middle of the donut shape is about 100 million years old. A cosmic toddler in astronomical terms. Our sun is 45 times older. The conditions are perfect for planets to form. But spectral analysis finds something strange. The dust is utterly pulverized. Typically, a newborn star is surrounded by fledgling planets.
Planets form around the young star in a protoplanetary disk of gas and dust. And then these planets go on their merry way orbiting the star, not realizing that they're in an orbit that's too close to another planet.
Millions of years ago, two primordial planets orbiting HD 23514 are spinning toward doom. As the two worlds close in, tidal forces torque each planet from spheres to egg shapes. Nothing remains. The two worlds are annihilated, creating the dust and debris seen around star HD 23514. 4 billion years ago, a similar apocalypse came to Earth. A Mars-sized planet forms in roughly the same orbit as the newborn Earth. Like the planets at HD 23514, Earth and this Mars-sized body are barreling toward each other.
If you happen to be unlucky enough to be standing on a growing planet when it was in the process of still becoming the Earth, you might wake up one morning and notice that the sky was getting darker and darker as a Mars-sized body was coming at you within a period of less than an hour.
And when it hits, the shock wave is felt all over the planet, scouring the surface of the Earth. The collision obliterates one side of the planet. Molten rock sprays out into space. The entire globe is peppered by meteors and noxious vapor.
It would actually make hell look like a Bahamas vacation.
The debris field from the collision coalesces and forms our moon. It is a new beginning for our planet.
Collisions are part of the birth process for planetary systems. Building up a terrestrial planet is probably all about colliding pieces of rock together.
And all across the galaxy, colliding pieces of rock are forming terrestrial worlds that defy the imagination.
There is a new planet out there, a planet we were not aware of existing before.
It is not just one planet. It is a new type of planet. Earth on steroids.
I like to call them super-Earths. They're just like the Earth, except bigger, up to about 10 times the mass of the Earth. One family that the super-Earths resemble just like our own Earth. Continents, oceans. Some of them may be very dry, like Mars. And then another family that we call water worlds or ocean planets that are completely covered with water.
Welcome to Gliese 581c.
This planet was found by Michel Mayor, and it orbits with 2 other planets around a very small star.
It's only 20 light years away, in the constellation of Libra and is one of the smallest terrestrial planets found beyond our solar system. That doesn't mean Gliese 581c is small. It's still a super-Earth with 5 times the mass of our home planet. But it's the possibility of liquid water that excites scientists.
An ocean planet feels like being in the middle of the Pacific Ocean, with no land in sight, just water, puffy white clouds, and blue sky above you. The winds on the ocean world are going to be similar to that of the Earth. So it will be a very good place to sail.
The weather's absolutely perfect. Every day you get a clear blue sky and the sun just stays in the same place. Now how's that for weather prediction?
No land anywhere. Even miles beneath the surface.
This water layer would extend very far down, at least a quarter of the way down in the planet.
But as we dive deeper into the sea, the pressure builds. At 35,000 feet below the surface, we pass the point where the deepest oceans on Earth bottom out. We pass the 100,000-foot mark. The pressure is so great, water itself begins to take on surprising new forms. At a depth of 10 times the greatest ocean depth on Earth, we reach the bottom.
When you have a large amount of water, then at the bottom of an ocean, you will form very high pressure in excess of 1 million atmospheres. And that pressure will compress the liquid water, that is the ocean, into a state which we call ice 7.
No, it's not like ice in your refrigerator. The molecules of water that are in the ice in your refrigerator are kind of all jumbled up. But if you form ice under very high pressure, then the water molecules can become ordered, they can become aligned.
I can show you a crystal that is a very good analog to ice 7. This is halite, also known commonly as rock salt.
Ice 7 may exist within our own solar system. Europa, a moon of Jupiter, could possibly have a mantle of liquid water surrounded by a thick, icy crust. The pressure from the crust is so great that Ice 7 might exist deep within these uncharted seas. If we scale up and thaw out Europa, it could be a water world similar to Gliese 581c.
One could imagine that life could emerge on a water world. After all, water is essential to life on Earth.
Everywhere on Earth where there is water, there is life. You cannot find a sterile drop of water on Earth unless you put it in the microwave yourself.
On this water world, there could be bacteria or any kind of life in the ocean itself.
But not all of the super-Earths are water worlds teeming with life.
When we talk about super-Earths, we talked about 2 major families of mostly rocky with some water and mostly water with an endless ocean. But one has to add to those a 3rd family of probably very rare super-Earths and Earth-like planets, which are called carbon planets.
A carbon planet is unlike anything we've ever seen anywhere. A place with an alien chemistry, but loaded with very earthly treasures. Throughout our galaxy, there are planets barren and poor and inhospitable. But science is on the trail of a new type of planet, an entire world of treasure.
In our own solar system, in our sun and in all the stars nearby, there's always more oxygen than carbon. But if we think of a place in the universe where there's more carbon than oxygen, then planet formation is very different.
Spectral analysis shows carbon to be far more plentiful 26,000 light years away near the center of our galaxy. Planets that form here may contain a rich abundance of carbon. The morning sky on a carbon world would be anything but crystal clear and blue.
I'm picturing a yellow haze with black clouds of soot. And as you descended farther down in the atmosphere, I could imagine lakes that were made out of compounds like methane or gasoline. I'm picturing these bubbling, foul-smelling pits of black ooze, like an oil well.
With little or no water in the atmosphere, the air is made of carbon compounds.
Methane, butane, pentane, benzene, all these different kinds of carbon compounds that separate out when you refine gasoline. One day it might be raining benzene. The next day it might be raining butane.
Alien as carbon planets might seem, the air quality could be familiar to some.
The air in a very benzene-rich planet will resemble that of LA. A lot of small particles that unfortunately we are quite used to from the exhaust of cars.
Despite the pollution, carbon planets could come with a sparkling upside.
You might see diamond because the planet may have substantial quantities of pure carbon that it's formed out of. And pure carbon, when you compress it, tends to form into diamond.
The secrets of exotic planets like these are waiting to be discovered all across the galaxy. But astronomers won't be satisfied until they find the Holy Grail. A planet like our own, one that sustains life, the next Earth.
People always ask me, do I think we're going to find another planet like Earth? And I answer, absolutely.
Every star probably has planets roughly the same size as our Earth.
We think that essentially every star has several Earth mass or super Earth mass planets. So if you have, say, 200 billion stars in the galaxy, that may mean there are 400 billion Earths in the galaxy or more.
400 billion Earths. The Kepler Space Observatory is the first instrument capable of finding one of these planets.
Kepler is looking at the constellation Cygnus in the night sky at 100,000 stars, taking picture after picture after picture, minute after minute. And the goal of Kepler is simple: to look for stars among the 100,000 that dim.
When a star dims slightly, it means a planet passes in front, blocking some of the light. How long the star dims and how much light gets blocked will tell scientists about the size of the planet and the distance from its sun.
A good analogy for this is looking for the dip in the light that you would see from a searchlight if a small moth flew across the searchlight. And so it's a really tiny dip in the light as the planet transits.
It is a very powerful technique because it allows you to discover planets that are even smaller than the size of the Earth around stars similar to the Sun.
It is a technique that is changing the course of science.
We think we may be able to find a planet that is habitable in the next few years.
Scientists estimate the Kepler mission will find a minimum of 50 alien Earths.
One of the big questions that anybody looking for life beyond the Earth is facing today is, what if we don't recognize life even though we discover it?
Conditions on an alien Earth may cause life to evolve differently.
My hope is that we'll see some sign that will make our hairs stand up on the back of our necks.
Whatever that sign is, it will be the first chapter on the greatest scientific story ever told.
– 2017 was a busy year for scientists of all sorts, the professional and the enthusiast alike. From a predictable astronomical rarity to surprise discoveries deep underground. It was a year that saw long-held beliefs challenged by newly found wonders. Breakthroughs that led to innovations. And a glimpse 130 million years into the past. In August 2017, alarms sounded at the most sensitive scientific devices ever constructed. In Washington State, the Laser Interferometer Gravitational Wave Observatory, LIGO, detected faint disturbances from deep space. The signal also hit LIGO's sister facility in Louisiana. Gravitational waves had reached Earth.
Gravitational waves are ripples in space-time. Space-time is incredibly dense. So to cause ripples, you have to have some sort of object that has enormous gravity, like a black hole or a neutron star. And when these objects are rapidly accelerating, they bend space-time and create these ripples that then travel through the universe to our detectors on Earth, like the one last August.
On high alert, the LIGO team quickly reached out to Virgo, its European counterpart in Italy, who confirmed that they too had detected gravitational waves. And then, as if by destiny, the stars would align once more to pave the way to a groundbreaking discovery.
Just 2 seconds later, with the Fermi Gamma Ray Space Telescope, we detected a short, bright flash of high-energy light that we call a gamma ray burst. This alerted the entire astronomical community to the fact that something very exciting was happening.
Using data collected from LIGO, Virgo, and Fermi, 70 ground and space-based telescopes scoured the edge of galaxy NGC 4993, some 130 million light-years away from Earth, searching for a small flash of light amidst a sea of stars. It would take less than 12 hours after the alarms rang at LIGO for Earth to have visual confirmation of a never-before-seen astronomical event.
What we saw was the result of the merging of two neutron stars. When they merged, they created an explosion in space-time. Those ripples went out across the universe as gravitational waves and were detected on Earth. The matter involved gave off gamma rays and other forms of light.
Neutron stars are the collapsed cores of massive stars left behind after a supernova explosion. No larger than a mid-sized city, these dense stars have 10 to 60% more mass than our Sun. This pair of stars, 200 miles apart, were locked in each other's orbit for over 11 billion years. But as they started accelerating and moving inwards, their orbit quickened from 30 times a second to an astonishing and unsustainable 2,000 orbits a second. Then, 130 million years ago, they collided in a resounding explosion. Peering into the past, telescopes were able to see the remnants of one of the universe's most impressive fireworks shows. A bright flash of blue followed the initial explosion, growing redder and duller as the days passed, until eventually fading to black.
the conditions around these merging neutron stars have densities and temperatures completely unlike anything we can do on Earth.
The violent explosion was observed to have produced 200 Earth masses worth of gold and 500 Earth masses of platinum, revealing for the first time the origins of heavy metals in our galaxy.
We think that all the gold in the universe was formed in explosions of this kind. After the explosion happens, the gold is spread out into the gas and dust of the interstellar medium. Later on, that gas and dust collapses into brand new stars and brand new planetary systems.
And these weren't the first gravitational waves detected by LIGO this year. 2 separate events have been measured before, including a pair of monstrous black holes that collided to form a single spinning hole, 53 times more massive than the Sun.
We received a perfect signal from this last merger. It traveled 3 billion light years to get here. In any given galaxy, one of these events might only happen once every million years, but we're now able to monitor about 10 million galaxies at a time. It's a new type of astronomy.
But while we wait for gravitational waves that can open a window on the origins of our universe, volcanic activity off the coast of Japan is presenting scientists with a picture of Earth's early history, when land first rose from the seas. Violent eruptions spew a steady stream of lava and rocks, expanding the newly emerged island of Nishinoshima, 3 square kilometers, in just 5 short months this year. These most recent blasts stopped in August, but could resume at any time. Situated atop the junction of 4 tectonic plates, the Japanese islands offer stunning insights about the formation of a variety of landscapes. There was no search for Zealandia. Mortimer and his team discovered the shallow submerged continent while performing geological work aboard a research vessel off of New Zealand's coast.
And so what the various geological investigations have led us to is that we do have the components of a continent here. When you pull the plug on the world's oceans, you literally reveal the continent of Zealandia.
Mortimer and his team confirmed 4 geological markers, the qualifying criteria for a continent: height, a varied geology or diversity of rock types, a thick crust, and ultimately size. Is it big enough? Corroborating data include rock samples, ocean drill cores, and satellite microgravity measurements, translated into bathymetric or elevation maps of the sea floor. Situated between the Pacific Plate and the Australian Plate, tectonic forces squeezed Zealandia, raising out of the water what we know today as New Zealand. With 94% of Zealandia underwater, the islands of New Zealand and New Caledonia are just the tip of this continental iceberg. And measuring in at 4.9 million square kilometers, Zealandia is 6 times bigger than the so-called microcontinent of Madagascar, and more than twice as large as Greenland, which also happens to be attached to North America. To understand Zealandia's origins, we must travel back in time to the time of the supercontinent Gondwana, comprised of what we know today as Africa, South America, Antarctica, and Australia. When Gondwana split apart 80 million years ago, it was a bit like the stretching of bread dough in a kitchen.
And then you start to pull that big lump of dough apart. And if you pull slowly, some of those pieces will stretch and get thinner.
Just like Zealandia, which broke off and slowly sank because of its relatively thin continental crust.
It's not as thick as the main continents, but it is thicker than the ocean crust. And geophysicists know that when you have thin crust, it floats lower in the mantle, and so it sits lower elevation-wise, and that explains, in very simple terms, why Zealandia is so submerged. Now that we've got Zealandia in the scientific arena, we do hope to consolidate it and to promote Zealandia in New Zealand schools, first of all, and we hope to get it in atlases, on globes. We hope that Zealandia will become as common and well-known as any of the other major continents.
Of course, the initial buzz about Zealandia can only help its name recognition.
The notion that something so big and so important could be hidden for so long, I think captured people's imagination.
Out of sight, out of mind, no more. Of course, not everything that's undetected is so obviously obscured. And one remarkable discovery this year offers clues about how some prehistoric creatures could hide in plain sight. In northern Alberta, Canada, the remnants of a 110-million-year-old dinosaur from the late Mesozoic era is providing the world with an unprecedented look at a new species, the nodosaur. A fossil so pristine and complete that it shows the texture, patterns, and color of a prehistoric giant.
The nodosaur is the best specimen we have, and it's the closest you'll come, until we find a better one, in terms of coming face to face with a dinosaur.
The nodosaur is next to surreal. A petrified beast caught by Medusa's gaze.
We knew it was good, but we didn't know how good it was. I think it's the best preserved armored dinosaur in the world. I'm calling this the Rosetta Stone for armored dinosaurs.
The anatomy of the new species has already given scientists clues to how these animals evolved, how they radiated and diversified through time. And it doesn't stop there.
The skin is preserved. It's not just the impression of the skin. We actually have some of the original biomolecules preserved. One of the cool things that they tell us for this specimen is that the animal had at least a component of reddish-brown pigment to its skin. The coloration aspect is very exciting. So it's cool to know what color it was, but it's actually more exciting when that has some implications for how the animal lived.
Researchers believe the nodosaur was darker on the back and lighter on its sides and underside, a method of camouflage called countershading.
Now keep in mind, this was a 5.5 meter long, 10.5 animal covered in armor, but it still has camouflage. And to us, that just illustrates how intense the predation was back in the Cretaceous. You had these very large meat-eating dinosaurs, and they would have also been very visual predators. So it actually kind of just shows you how extreme that ecosystem likely was back in the Cretaceous.
The plant-eating, slow-moving beast only stood a chance because of its impenetrable coat of armor.
We see 3 rows of osteoderms. Those are what are called cervical rings, and it's armor that would have protected the neck of the animal. And as we move to the side, we see this giant parascapular spine. It's basically a big armor spine coming off the shoulder, and it's about 0.5 meter long.
And the spectacular specimen still has many secrets to unveil. The next focus of study are the contents of the nodosaur's stomach.
In addition to having skin preserved all over most of the surface of the animal, we also have abundant gut contents. So the last meal of the animal preserved inside. And this is what that stuff looks like. So we're currently doing all sorts of work on this, geochemical work, histological work, and CT scanning, trying to figure out what these spheroid structures are. And there's been many ideas that part of the diversification of dinosaurs is tied to the diversification of flowering plants. And it would be great to see exactly which types of plants this guy was eating, and if that hypothesis makes sense.
We know what dinosaurs ate, how they fought, and now what they looked like. But but there are still many questions to be answered. And Alberta might just be the place to find them. It's estimated that there are thousands of fossils hidden underneath the Earth. But when a 6-mile-wide asteroid struck the Yucatan Peninsula 65 million years ago, dinosaurs had nowhere to hide. And the resulting global cataclysm of earthquakes, firestorms, and tsunamis ultimately led to their extinction. Some animals, however, managed to survive. But how? Since its discovery in 1978, investigations of the asteroid's impact crater include data from seismic images and recently collected core samples from deep within the site at Chicxulub. The data paints a devastating picture of destruction and led scientists to create a broad new survival theory, focusing on habitat and diet adaptability. When dinosaurs perished and a vast new ecospace emerged, the surviving species expanded rapidly to fill it. This is called adaptive radiation. A recent study shows that 1 out of 10 frog species descend from the original 3 frog species that survived the Cretaceous-Tertiary extinction event. Frogs were able to escape extinction for a number of reasons. They live in an aquatic habitat that offered protection. Their small size and unique metabolism allow for better endurance of environmental stress. Eventually, when vegetation returned, they were able to diversify worldwide and adapt to new lives in trees. Birds, too, exhibited the same adaptive radiation around the same time. A newly found 62-million-year-old mousebird fossil in New Mexico helped paleontologists map the diversification of land birds, which can be traced back to 9 original ancestors which survived the event. Warm-blooded, birds' feathers insulated them from temperature extremes. Their small size and ability to fly allowed for easier escape from hostile and barren terrain. And their diet of seeds, worms, and insects gave them the edge after much of the Earth's surface plant life had died. In the end, the ability to adapt to changing conditions proved a key characteristic for the survival of many ancient animals, including our smallest mammal ancestors. Just as it may be for humans today, as we confront the challenges of climate change. The city of Miami Beach already knows what it means to wade through sea level rise. In recent years, residents have experienced elevated high tides at certain times of the year. Known as king tides, these events are clear evidence of incremental increases.
Right now, we are definitely witnessing sea level rise impacts, these high tide flooding events that are growing in severity, more often, deeper, more widespread. That's sort of a pattern that we expect will continue.
That means huge financial costs by the year 2100. Another predicts 2.5 million Miamians could become sea level refugees and leave the area. It's not only Miami. All around the world, sea levels are expected to rise. The question is, by how much? In adopting a multi-pronged approach, Miami Beach has committed $400 to $500 million to combat sea level rise, building water pumps and raising their defenses.
With the continued issue of climate change and sea level rise, we're seeing an increase of water level every year. We had to make changes to adapt to this future condition. What you're seeing here, we put a boardwalk initially to give some height, but we found that that wasn't protecting the city. What we've done here is we've increased the levels of our new seawall. The new wall you see in the background here is our new standards. This is good for approximately another 50 years, and we're going to see water levels challenging even that new seawall.
Raising its elevation, Miami Beach seeks to stay dry and take control of its future.
The city's philosophy, our culture, is rising above. We believe that we can meet the challenge. And the challenge is not only in rising above, meaning elevation, it's rising to and withstanding the challenges that come with sea level rise due to climate change. As a city engineer, I have complete faith that we can win. We can mitigate. We can survive.
Of course, the Earth's oceans have risen and fallen many times during the planet's history. And new archaeological evidence suggests these shifting shorelines may conceal clues about the earliest Americans. Until just recently, archaeologists generally agreed that the earliest people to populate North America were the Clovis people, dating back to some 12 to 13,000 years ago. But a group of scientists in San Diego, California, have a different theory.
We have the bones, the fossils, the distribution, the rocks, the date. We have evidence for humans in North America 130,000 years ago. We realize that that is a startling claim.
But the scientific community is struggling with the idea that humans arrived in North America 130,000 years ago.
The study of early humans in the New World has been very political and very controversial for over 125 years.
It's an old mystery yet to be solved, deciding who got to North America first and when.
Welcome, and thank you for joining us this morning at the San Diego Natural History Museum as we share some exciting news about a discovery made right here in San Diego.
Well, back in 1992, Caltrans was doing improvements to State Route 54, which involved adding a couple new travel lanes. And Richard Cerruti, who's a field paleontologist here at the museum, was monitoring the excavations on the very north side of the freeway alignment and saw this little puff of let's say, tusk material being scraped up by an excavator and said, "Stop, let me go look at this."
The bones that Richard Cerruti found belonged to an ancient mastodon.
That's one tooth, so and it's characteristic of American mastodon.
Were these giants sharing North America with early man 130,000 years ago? The answer may lie in the position of the bones and tools found at the site.
There are anomalous fragments of rock, anomalous fragments of tooth enamel scattered throughout the site that just don't make sense.
Could these stones amongst ancient bone remnants have been an early form of primitive tools?
And we felt that it was important to produce a map where we carefully plotted or precisely plotted the position of all the bones and the stones or whatever else is in there, so that we can understand what the general pattern is.
It's thought that the tools found with the mastodon bones were used for butchering the animal.
So this is one of the cobbles that we hypothesized was used as a hammerstone 130,000 years ago, where there was a carcass of a mastodon. These people were trying to recover raw materials from it. They had a problem. How do we break these bones? They look over into the active river channel, find some cobbles of the appropriate size and weight, bring them back to the site. And if you look closely, there's some striations coming off of that are indications of where this flake has come off.
The cuts in this rock led the San Diego team to conclude that these were actually tools used by humans. An idea that Demir says might not be so far-fetched. Dr. Stephen Holen is co-director of the Center for American Paleolithic Research in South Dakota. He was part of the team that evaluated the findings from the San Diego excavation site.
So what do we got in here, Steve?
like vertebra.
It does.
I said, I can't get my mind around this. This site has to be really, really old, but yet here's evidence of humans. I said it goes against everything I thought I knew and everything I have ever been taught.
Holon evaluated the mastodon bones and the stone tools recovered from the excavation site.
We would take the drawers out of the cabinets in here and bring them in on this table and look through them, paleontologists and archaeologists together. Richard Cerruti came in, so there were 4 of us, my wife Kathleen, Tom, and I, and we would look through and we would look for these very diagnostic pieces. And one of the things that we got all excited about first were these cone flakes that form in a circle around the point of impact from the hammerstone. And based on the experiment that we'd done in Africa, breaking an elephant femur with a big hammer, we saw the same kinds of fracture patterns that we did experimentally.
Holon specializes in evaluating broken bones at archaeological sites, looking for human causes, as this video shows from a test he conducted in Africa 2 years prior to working on the San Diego project.
Oh my God.
As we puzzled over this, we kept coming back to this one explanation that explains all the data, was that humans did this.
The detective work by the San Diego Natural History Museum team was capped by the age dating that Richard Cerruti had done to prove the age of the mastodon bones he discovered.
This is one of the specimens that he used in his analysis. He cored it and he also sliced it. And after analyzing over 100 microsamples from this specimen and 2 other specimens of bone from the site, yielded an age of 130,000 plus or minus 9,000.
So after the article came out, there has been no critic come out to say that the dating is incorrect. In fact, other specialists in uranium series dating have come out and said the dates look perfectly good. So we're very comfortable with the dates.
While humans' arrival in the Americas may have occurred earlier than previously thought, new dating of another paleontological find, found in a South African cave, could soon upend long-held theories about the evolutionary tree of primates and early humans.
When we actually got into the chamber and could start removing it, we realized that not only was there one individual lying there on the surface, but the floor was literally comprised of Homo naledi. There are thousands and thousands and thousands of remains down in those chambers, and all you have to do is sweep the surface off, and there they are.
So the first time I sort of slid through that hallway into the open area where the chamber is and sort of started looking around, you know, you're only wearing a headlamp, so you just see flashes, but every flash of my headlamp showed bone. So I think right at that point, I realized that we had a lot more than the original photographs actually had portrayed. So that was pretty exciting.
Homo naledi isn't really similar to any known hominid species in its entirety of its package. You've got little bits and pieces of almost everything we've ever found. Parts of the skull, if you just look at it quickly, look a little bit like Homo erectus. Got a very small brain. Other parts of the skull look very modern, like Homo sapiens. It gets stranger and stranger as you move down the body. You get the ape-like shoulders. You get these more and more human-like arms, which end with a hand that's human proportion.
I was actually at the London Natural History Museum, and Homo naledi was on the wall, and then there was estimated age between 1.2 and 1.8 million years. But then, when we actually did the scientific dating of those teeth, this is when things got very interesting, because then we got an age of 200 to 300,000 years old.
When we got a date, it was much younger than that, 250,000 years, give or take, we realized that we were dealing with a primitive creature, almost like a time traveler, that had come down from deep times to a point where it is very possible that Homo naledi was in direct contact with the emergence of modern humans. We never thought that was possible in Africa. Until this moment, we thought that there was effectively, during that entire time period of the Middle Pleistocene, late Middle Pleistocene, one form, a big-brained form of Homo sapiens. Now there are 2, and that adds incredible complexity to our record.
The world of Homo naledi and other early humans was different than it is today. A veritable Garden of Eden, teeming with life. pure and free from pollution. Few places like this still exist, and most of them quite remote. But look just a few feet underwater and you can find one of the most productive and overlooked ecosystems on Earth. Scientists recently learned that seagrass meadows help scrub the surrounding water clean of bacteria from raw sewage and other pathogens. A recent study of polluted waters in Indonesia showed levels of harmful bacteria to be 50% less in spots with robust seagrass beds, leading to healthier fish and coral in the surrounding area. You see, seagrasses oxygenate the water, trap sediment that might otherwise float freely, and host tiny microbes that kill many harmful bacteria. Eliminating toxins improves the health of any system, and the workings of a human body is no different. In athletics, though, they say no pain, no gain. A nod to the physical effort required to increase endurance and enjoy the health benefits of exercise. But new pharmaceutical research also aims to make those benefits more easily accessible.
The potential benefit of a drug that can tune you up in the way in which you normally get tuned up by exercise could have really dramatic effects.
Playfully known as the exercise pill, the experimental drug shifts metabolism by triggering genetic instructions for the body to burn fat instead of sugar during exercise, something that doesn't normally happen until after extensive training and conditioning. Recent tests increase the endurance of otherwise sedentary mice, which also proved to be resistant to weight gain while on the drug.
We have two groups of mice, and one group on the drug, the other group has a control without the treatment of the drug. So we were quite surprised to see the astonishing results. The mice treated with the drug, they can run almost 100 minutes longer than the one that are not treated. The increase was around 70%.
Researchers ultimately hope their product can improve the health of the disabled, elderly, and obese.
There are many reasons why people can't either walk or run or exercise. And the idea is if you can bring a small molecule into the picture that can confer the benefits of fitness without training, you could really help a lot of people.
From energizing our bodies to powering societies.
So we are just waiting for the next experiment. It's going to happen in 10 seconds. There you go. You see the flickering of the plasma? We are creating fusion here. This is our little sun. It's extremely hot.
Each day, every 20 minutes, researchers build the sun. At the Culham Fusion Centre in Oxfordshire, Britain, generating temperatures greater than 200 million degrees, these nuclear fusion trials would be impossible without JET, the Joint European Torus, a donut-shaped plasma containment vessel.
At this point, we're the most important experiment in the world.
Thanks to JET, where energy is created by combining hydrogen atoms.
Right? There's heavy hydrogen, which we call deuterium, and the super heavy hydrogen, which we call tritium. And when they're running around at these temperatures like 200 million degrees, they bang into each other with immense speed. And when they do, and they get close enough, what we call the strong force, which binds the nucleus of atoms together, grips them, pulls them together, and they fuse, and they make helium, and they spit out a neutron. Fusion really is the perfect way to make energy.
And yet, despite fusion's transformative potential to provide safe and sustainable energy to the world, the program faces an uncertain future. While the British government committed to pay for its share of the experiments up to the year 2020, Brexit, its planned departure from the European Union, may also lead to the UK's withdrawal from scientific agencies like Euratom the European Atomic Energy Community. Some say this could jeopardize jet logistics and operations, and perhaps also the larger next-generation fusion experiment, currently being built in southern France. If fusion represents harnessing the physical power of the sun, a moment of darkness reflected its emotional power. An awe-induced euphoria experienced by millions as the first total solar eclipse over North America in 3 decades made its way across the United States.
It's the most unnatural natural phenomenon I ever saw.
This is a solar eclipse, and just what people witnessed on August 21st along a 70-mile wide path. First along the Oregon coast at 10:15 a.m. Pacific Daylight Time, and last in South Carolina 94 minutes later. The uncommon coupling was the most viewed and photographed eclipse ever recorded. And yet, even as the sun re-emerged from the moon's shadow, some earthly domains remained, as always, far removed from its rays. Like the cave chambers, 300 meters below Mexico's Nica mine. Enormous, razor-sharp crystals dwarf human explorers. While today the cave is totally submerged, previous expeditions collected bizarre life forms from these crystal giants. They call this place Hell on Earth. Temperatures climb to 135 degrees Fahrenheit, with over 80% humidity. Even with life-saving bodysuits, no visit can safely last longer than a half hour. Yet deep within this extreme environment are life forms which exist nowhere else, known as extremophiles. NASA astrobiologist Penny Boston and her team found 40 strains of mineral-eating organisms. Trapped within the crystals here, they collected sample microbes, some dormant, but alive, estimated to be between 10 and 50,000 years old, including genetically unique and previously undiscovered life forms.
Any extremophile system that we're studying actually, allows us to push the envelope of life further. And we add it to this atlas of possibilities that we can apply to different planetary settings.
By expanding the definitions of life on Earth and where to find it, Boston's findings could impact the search for life beyond our planet. On places like the protoplanet Ceres, the largest object located within the solar system's asteroid belt, and one of the scientific targets of NASA's Dawn space probe. And in February of 2017, startling and unexpected news began coming in.
My colleague found a spectral signature in her data that is consistent with, or the same signature of aliphatic hydrocarbons. So here we're finding maybe the building blocks of biological material.
Seen here in red, the organic materials are thought to have originated in the dwarf planet itself. Dawn's study of Ceres also revealed evidence of water and volcanic activity, further raising the scientific profile of Ceres, no longer considered a barren rock. However, Dawn isn't the only NASA spacecraft uncovering new surprises about our solar system. – 7 months after arriving in Jupiter's planetary system, the Juno Explorer became fully operational in February of 2017. Astonishing researchers with the steady stream of images and scientific data it's sending back to Earth. Jupiter is by far the largest planet in our solar system, leaving Juno with a whole lot of ground to cover. And although it is the second brightest planet in our night sky, its formation and composition have left us in the dark. Previous NASA missions have given us some understandings of its moons, small dust rings, and atmosphere. But we've not been able to see past the Van Gogh-like swirls of dense red, brown, yellow, and white clouds that paint the planet. At least, not until now. Each individual image is awe-inspiring, especially those captured when Juno came within 5,000 miles of Jupiter's Great Red Spot, the planet's most famous storm. Poring over data from Juno's microwave radiometer, scientists hope to learn more about what powers the tempest and how it differs from other Jovian storms. This critical instrument measures 6 distinct ranges of thermal radiation as it peers more than 300 miles beneath Jupiter's clouds to create a three-dimensional model of Jupiter's atmospheric environment.
So the first time we're looking inside of Jupiter with into the interior, and what we're seeing is that it doesn't work at all like we had predicted. Almost every model that has the interior motion, how the magnetic field, the gravity field, how the deep atmosphere works, it's all different.
Current modeling estimates that the cloud cover is roughly 30 miles thick. Below it, there lies a 13,000-mile layer of swirling hydrogen and helium that changes states from gas to liquid as it nears the center, leading to a 24,000-mile deep sea of metallic hydrogen.
If we can probe it and work out the abundance of elements in it, hydrogen, helium, the higher elements as well, and work out roughly what that mix is, it'll tell us something about not only how Jupiter was formed, but how the solar system might form.
If there is a bunch of rocky material in the center of Jupiter, it means that in the early solar system, before Jupiter formed, that rocky substances were probably coming together and Jupiter got built around those. It could be that Jupiter was built without any of those and that it just collapsed sort of like the sun and there is no rocky material or core of heavy elements in the center.
Strangely though, gravity data collected so far points to a new possibility. A somewhat larger than previously thought and perhaps partially dissolved core, leaving Jupiter experts with more questions than answers.
We're putting the pieces of the puzzle together, and it's exciting, but we don't have the whole picture yet.
Juno's primary mission is scheduled to continue until February 2018. But this past year, NASA saw another of its extraordinary explorers come to the end.
And we are in the atmosphere.
As the Cassini space probe plummeted into Saturn's atmosphere in a fiery death spiral.
Roughly 1 minute to loss of signal.
The culmination of the craft's revolutionary scientific quest.
Call loss of signal at 115546.
The signal from the spacecraft is gone. Congratulations to you all. This has been an incredible spacecraft, and you're all an incredible team.
She has rewritten the textbooks about Saturn, the rings, the moons, Titan. So many things have changed because of Cassini.
From its launch 20 years ago to its bold grand finale, the Cassini-Huygens mission has unveiled some amazing discoveries. Saturn is ablaze with storms of unimaginable force. The place crackled with giant lightning strikes. The rings are even more dazzling than imagined, stretching across hundreds of thousands of miles. they're made of particles of pure water ice. Some microscopic, some the size of mountains.
They break apart and they reform, so there's this beautiful cosmic dance going on inside the rings.
Cassini also carried a little lander called Huygens, which became the first probe to land on a moon other than our own. Its target, Titan, because of its atmosphere.
And as those first pictures came back, we just saw more and more haze and fog and haze and haze, until finally the probe broke through that haze and we got to see the surface of Titan for the first time.
Next, Cassini then captured giant jets of water spewing hundreds of miles into space from the Tiger Stripes, shooting out at 1,200 miles per hour, vaporizing and then freezing. Back on Earth, Cassini's stunned controllers quickly reprogrammed the probe to fly right through the jets, collecting particles. And what they found was even more stunning. Organic molecules, the basic building blocks of life.
Enceladus is really special. It's giving us free samples.
Because the geysers are erupting and they could guide the spacecraft very close and look to see if there's water there, and there is water. Here on Earth, wherever there's liquid water, whether it's deep in the ocean and very hot or in rocky places or in ice, there's microbial life. So it certainly suggests microbial life could have evolved on Enceladus because it has all the properties that the Earth had when life began here.
NASA controllers plotted the probe's deadly descent into Saturn's atmosphere. Productive until the end. Cassini relayed detailed information about the planet's environment. And then she burned like a meteor and vaporized. Scientists will build on Cassini's contributions as the search for extraterrestrial life continues within our solar system and beyond, perhaps around the star system 39 light-years away, known as TRAPPIST-1. The first place found, NASA announced, to have multiple planets. 3 here, circling a single star inside the habitable zone, where liquid water can exist.
Well, with this discovery, we've made a giant accelerated leap forward in the search for habitable worlds and life on other worlds, potentially speaking. The TRAPPIST-1 system has really captured our imagination because with this amazing system, we know that there must be many more potentially life-bearing worlds out there just waiting to be found.
Earth-like in size and temperature, these 3 faraway worlds suggest endless possibilities.
The discovery gives us a hint that finding a second Earth is not just a matter of if, but when. These questions about are we alone are being answered as we speak in this decade and the next decades. So I'm really excited about this.
It's been an astonishing year for sure. And as our universe reveals more of its secrets, far out in space and closer to home, our foundation of knowledge will continue to grow, promising ever more to come.